So finally, we're now at the point of the actual textbook, and sort of talking about the first sort of bit of our journey together, which is going to be on the introduction and then problems and problem solving. All right. What we've noticed with students who come in, especially who haven't really programmed before, we really are trying to drill in the idea, the meta idea of problem solving into your coding. And I got other ideas as well as we start going through this. So I'm not surprised in my conversations with Sam. I'm not surprised that that this is sort of one of the deals that he sort of wants to drill home a little bit. Now, a couple of other quick things about this, by the way, something I just kind of discovered. If you're ever bored, you can actually have this thing read to you. So there you go. Because you can have this thing read to you, I'm not going to read it to you. So by all means, this doesn't replace you looking at the material and just sort of and there really isn't that much. I think you'll be fine. So anyway, so this particular part today is going to be is meant to talk mostly about problem solving. All right, so let's go to the next page, and apparently the next page, and now we're basically on chapter 1. And by the way, if someone can figure out a way that I can shrink this down, that would be great. Because if you're thinking it's the mouse scrolling button, no, it's not, and it's driving me crazy. Sam and Steve put in a little thing along the side here, a little glossary, if you want, as we go. So definitely look at that, because every now and again they'll give you a definition like programming is the active job of writing computer programs. Now, that's great. It's a good definition. I'm not going to critique it. The only thing I am going to critique is then what is a computer program, right? So programming is the activity or job of writing computer programs. What the heck is a program? So my best example of programs really kind of comes from recipes. And when I'm thinking about like banana bread, for example, how do you make banana bread? Well, these are all your inputs. This is the program, the steps that you follow that would then make the bread. And then the bread itself is the output. Although this particular idea isn't accented that much in this book, a lot of other books had this idea, and I definitely am a big fan of it. You have to, at this level, you really should be thinking about programs as having things that come in, stuff happens to it, and then probably something comes out. Inputs, processes, outputs. And so that's basically what a program is. Now, I'm going to start using some more advanced words later, but I'll tell you, every now and again, I'll use the word algorithm and people will freak out, because especially if you've got beaten up by math teachers in the past. But algorithms, this is an algorithm. It's basically a formula that takes a bunch of inputs, you run it through and spits out an output. That's an algorithm. This is an algorithm as well. And your programs are ultimately going to be algorithms. All right, so, and you as a programmer will be creating those programs. All right, so enough of that. Now, what about problems? Well, what Sam and Steve have done is they've kind of introduced this idea, a bit of a typo, by the way, step 1, step 2, step 3, step 4. I want you to imagine this is sort of a circle. But the deal is there's got to be a reason you're writing the program. So what's the problem behind that you're trying to solve? And don't just skip to the end and start typing code. What is the actual problem you're having to solve? So I would say, for example, in my life, just a really easy one is my problem was that my problem was that I was trying to get a dynamic distribution list for emails. That was my problem. And then I determined the cause. Well, what was the cause? Well, in this case, the cause was that the interface that I was using couldn't handle first of all, it couldn't create a distribution list and couldn't handle the way I was putting them in. That was the cause. So what are some of the solutions? And there are usually multiple solutions. So you're going to want to sort of work out what's the best solution. And, one solution is what I told you guys I did before is I wrote a sort of a Python scraper kind of thing that would go open up an Excel spreadsheet, pull it out, make them into a nice little distribution list. That was a nice solution. Another solution would be to continue doing it by hand. That's another solution. Maybe I could have done the thing in C. That's another solution. There's a bunch of different sort of solutions that come up. Then you got to sort of pick the best one that you think you've got and then implement it. And a lot of times we spend a lot of time in this course over here. And I'd suggest to you that a lot of your training is going to be ultimately in how to implement. But you've got to sort of define, like, what's the issue, what's causing the issue. I actually found in one case, the cause of the issue was something that we could have actually stopped. So we stopped the cause, and then that more or less stopped the circle because we said, well, we don't need to do that thing that's causing the issue. Boom, out. That's it. The cheapest, easiest program is one that you don't have to write, right? It's also the most maintainable. So, so definitely think about that. What are the causes, and then what are the solutions, and then you basically pick the better one. Now, what Steve and Sam have done is they actually have several different problems, and that they want us to think about, in a structured way using that using that circle. They don't have the circle here, but you'll recognize: define the problem, determine the causes, identify solutions, and then basically pick one of the solutions and then implement. And the Apollo example is actually a pretty good example because if you haven't seen Apollo 13, probably a good thing to see. This is actually based on Apollo 1. And Apollo 1, by the way, actually killed people. So I would rather, I don't really want to talk about this that much because I'd rather you guys sort of work through them. But basically, you look at this text here, and then using that chart, what's the problem? What was the cause? Identify the solutions. Implement a solution. Now, they kind of give you some text here. Now, I'm going to tell you, spoiler alert, what would normally happen is that we break into groups and you talk about this and then you come back together. That's what would happen. We're not doing that now because it's completely online. But they actually have a solution a few pages forward, right? They'll actually have the solution for this problem, the Apollo problem, the Mars lander, and the COVID. Now, I think it would be good for you to sort of just at least think about it and then compare your solution to their solution. Don't worry too much about whether you're right or not. The whole point here is the methodology, basically taking a problem and breaking it down. An interesting thing, by the way, when I was talking with Sam about this, I actually was at, well, I think it was at NASA or JPL. I was actually there for a party where we were going to celebrate the landing of the Mars lander. I was there with Bill Nye and John Glenn, and it didn't work because it crash landed. So so I kind of like that like that failure. And another interesting thing about that failure, by the way, is they give you here what the failure was, but in many cases that was a failure in PowerPoint because too much information was just being put onto PowerPoint screens and no one caught the fact that, wait a minute, we're converting stuff from one unit of measurement to another improperly. So so there you have it. Since then, by the way, there's been other big messes that have been created by IT. One of my favorite examples is the European Space Agency lost something to the effect of $4 billion of satellite equipment on what amounted to a division by zero error. The navigational computer was doing its business, telling the thrusters which way to point. It did a divide by zero error. And for those of you that don't know what that means, if you take 2 and you divide it by 1, you get 2. You get 2, you divide it by a half, you get 4. As your denominator, oh boy, the bottom one anyway, as that one shrinks, the top one grows, And all of a sudden, if you divide something by nothing, it doesn't make any sense. Most computers generate an error. We'll talk about this in error processing, but I'll tell you at this point, if you have a system that generates an error and nothing's trapping that error all of a sudden got fed out to the navigational computer as coordinates, basically, as ways to point the rockets. And as you might imagine, an error message being interpreted as navigational data was bad news for that rocket, and it blew up. And the only good thing that we have is that no human lives were lost in that. So what I would do if I was a student is I would basically look at these problems. I would see what I can do with these problems. I'm not going to talk about the Python installation in this video. I'm going to do it in another video. But back just past that, that's where you'll see the actual solutions. All right. So anyway, you can cheat all you want on this one. Just we're trying to basically get your brain to shift. All right. So in the next video, I'm actually going to take us through the various Python environments that you can use. And then probably in a video after that, I'm going to try and take us through our first Python program. All right, so that's it for this one.